Do people not have edit access to the doc for some reason? I'm still not sure what's going on there for notes.
Yeah, I don't seem to have it. Do I request it somehow?
I am not sure. I thought maybe the Google group had it or something else, or maybe I can, let's see if I can grant. So anybody in the Apache Parquet community sync at googlegroups.com can edit it. So if you join that Google group, you should be able to edit it.
Okay. I did join. Let me try again. I'll double check. Thanks.
Name needs to be approved.
And I'm not sure how that works on the Google Calendar side of things, but I think when people join the list, they don't automatically get the invite on their calendar, right? It's kind of, so it's like what I've done in the past is kind of uninviting or inviting or something, and then they get it. But I don't know if there's a way to work around that.
Yeah. This was about being able to edit the notes doc instead of suggestions. So hopefully you don't need to do any sort of re-adds there.
Yeah. And just I'm hesitant to send an email with the link to the call, because I've done that in the past, and invariably, there are people you just bombing meetings and you just do random things, right? So I've done these mistakes before. It's kind of okay. Don't send a joinable link to the internet. That's a bad idea.
Wait a minute, you're saying there's trolls on the internet?
Apparently, like, who knew, right? Yeah, we have a guy, it's just he joined it, he put one, they use those kind of avatar, like virtual avatars, and they start like saying random things, like just being trolls, basically.
Yeah.
And so like that, but it's distracting.
There are trolls, and there are also people that are wrong on the internet, surprisingly.
Oh, right. Tell me about it. I just saw a talk by Will Manning, the doc from Vortex fame, who's telling us that Parquet is ossified and you cannot change it. And so I'm like,
He sent you a direct note, or there's like a.
He gave a tech talk at my job.
Okay.
I politely listened and didn't interrupt.
He also did the same talk at the CMU seminar series, and I think the YouTube link for that's up right now. I think Andy's.
It's a very good talk, right? Yeah,
it is. I watched it. I'll post the link in this channel. It's good.
So I'm just, I just disagree on some aspects of it, but variant is shown as an example of Herculean effort that but I think like right. So if we made it happen, that means we can do things, right? It's kind of everybody wants people to contribute, to collaborate on their project, right? Which is like yes. Of course.
Well, there's a difference too between like it's open for read, like the spec is open for other people to read it versus it's open for other people to write it.
Yeah,
like modifications to it. I think that's a important distinction that's perhaps sometimes not made.
I'm preparing. I've been sharing with Andrew. I'm preparing a talk. So I think it's next week or the week after. I think it's next week. I'm speaking at the it's a meetup at Snowflake in the Bay Area, and I'm going to talk about how all those new format put a healthy pressure on Parquet to evolve, right? And the argument is there's not such a fundamental difference, right? Of course, none of the existing Parquet encoding were designed with random access in mind. So of course, you're going to have like a much better performance on things. And also, I think the whole parallelism aspect is a bit lacking, right? So we can write sure parallelism. We can do much better things. There have been a few papers recently. And I think it's up to us, like whoever is in this room, to make it really easy for people to contribute an ALP or FSST or something else in there.
Are you going to be at Snowflake in person?
Yes, I am. It's I can send you a link.
Awesome. Yeah, we'll meet you there.
By the way, I tried to sign you up, Julian, to speak at the CMU talk series. I'll see. I said like.
Oh, okay. I need to.
I'm only kidding. I'm only kidding. But I was like, if you're gonna put people on bashing Parquet, we should have at least the other perspective that talks about how gives the Parquet's perspective.
Yeah. I was saying, like they say, Parquet is slow, right? Like, so my argument is Parquet is slow because we're pulling and we're getting, you have Snowflake, we have Databricks, we have Google, we have CMU, we have Data Fusion. It's like, oh, let's get to agree on how we push things forwards, and then we push it, right? If so, there's a saying that says, if you want to go fast, go alone. If you want to go far, go together, right? It's kind of, you're going to go faster if you don't have to deal with other people's opinion as much, right? But yeah, hopefully we can do that. We can have a nice group. Maybe we should add the chit chat section to the Parquet sync at the beginning, like it's just officially part of the agenda.
That saying, if you want to go slow. Over the headset now.
Sorry,
that saying you want to add? I'm just going to put that on top of the.
Oh yeah, if you want to go fast, go alone. If you want to go far, go together. Right?
We should put that on the Parquet website.
Because, I mean, all the work that's being done is great, and it's like this is the direction things should be going. And then it's up to us to kind of, just put good pressure on Parquet. And it's just the baseline is going to get better. And instead of, a lot of X, there'd be a lot fewer X's,
Yeah, I think, I have opinions on the Linux Foundation. Open source projects.
So this is the LFAI in data. So I am actually on the technical, the technical advisory console for this LFAI in data, because this is I'm the lead for Open Lineage, which is in that same foundation. This is where so I think it serves its purpose. I think in terms of neutral governance, I think it works, right? But yeah, I don't know.
I guess I'm curious if that allows spec changes. Does it not? Anyway, we can get started.
Yeah, let's get started. Like, okay, we'll have to do a Parquet water cooler some of the time. Like, let's schedule a Parquet water cooler thing or something. I don't know. Okay, welcome everyone. This is the official. We 9 minutes in. I think like we have a lot of people. But this is interesting. I think there's lots of interesting things happening. So what we're going to do. Where's the chat? We're going to do the Alkis way of building the agenda. So actually, let's. Andrew, can you pin actually, or maybe I can just post it, because if you pin your message in the chat, then people who join after you posted it will still see it. I think I need. Oh, right. Oh yeah. Oh,
I-
you can-
Okay, I
oh, yeah.
never-
Now it's been 3 times. Okay, that works. So but let me check the doc. Right. So we October 15th. Sorry for me, you don't read calendars well. So please go in the agenda section for today. So put your name and where you work, if you feel comfortable sharing, right? Like you don't have, if you just want to listen in and rather nobody knows you're here, it's okay. You don't have to list yourself, but it's useful, right, to remember who was here. So you can put your name, where you work if you feel comfortable, what you want to talk about today, and it's okay to just be listening and have nothing to talk about. And you can join, you can share in the agenda section what you want to talk about. And then, I'll try to do my best managing time so that we talk about stuff. And oh yeah, so talking about new encodings for Parquet, I see we have a topic. So okay,
So yeah, I added that.
yeah.
Okay.
So just 1 second before we start, and just want to check. So Arnav, there's suggestions for cookbook. What is that about? Do you want to write?
Hey, Julien.
Yeah.
Yeah, would really appreciate if in the last 5 minutes we could discuss it. I think a couple of folks raised some issues about documentation, so I was working on a cookbook. I just wanted some suggestions, what you guys think could be added, anything that's missing. Maybe in the last 5 minutes we could discuss that.
Okay, let's do that then. Then I think any last, so and for people who are new, I've never spoke here. It's okay. It could be, whatever. It could be just bringing attention to a PR you want people to review. It could be a thing that you think you're not sure and you want to hear and get feedback. I think, okay, so, and logical, yeah, and maybe, yeah, and then when we get to the topic, I'll ask you to just quickly explain what you want to talk about. Okay, let's go. That sounds good. We'll keep 5 minutes at the end to talk about that. Prateek, you can go.
Hi. So a couple of months back, we said that we wanted to evaluate and possibly talk about a few encodings in the Parquet world, and we wanted to help out, evaluate, and contribute for some of the encodings. So we just got around to get some numbers, late last night, and wanted to share with the community and how it looks like. So with that, I'm gonna share my screen. I haven't sent out the doc yet because. Oh, wow. I need to give it permissions. 1 minute. Because we just got to it yesterday. I'm going to have to quit and open the Chrome again.
Oh, yeah, you need to restart. Yeah. See you in a second.
See you. Yeah.
Yeah. And the last, so also we added logical type for scaled integers. Who added this?
I did. I'm Andrew Bell.
Okay. Thank you, Andrew. So we can, we probably talk about it right after.
Google should have a slightly better way of not having to restart. Come on, what is it?
Sorry. Yeah. I also get confused because I usually use Zoom and they all work in slightly different ways. And the first time you try to share, they don't have the rights to access your screen. Right? Here we go.
Okay, I think you guys show my screen.
Yeah.
Okay. Okay, that looks like the right screen. So because I wanted to share the document, not just the numbers. So I started off with why we have encodings and compression, and where do they stand, and what do they exactly contribute. Encodings look at they look at the domain of the data, they look at the data type, and figure out what's the right set of things to do. In compression, block compression, just add on things to look at byte by byte values. We currently have plain and byte stream encodings, and then people can slap on any compression that you want on top of it. With that, there was a very good paper that came out which talked about a new encoding, ALP, which mentioned the clear, what are the possible things that we have right now and what can be possibly evaluated, along with, what generally sits out there in terms of how you can slap on compression on top of the current encodings. With that, they bring up a very important point. Let's look at the current set of encodings that exist out there, and where do they stand. They definitely help in some aspects, but they clearly don't look like lightweight. When you look at the decompression space, they stand alongside the various block compression schemes, so they don't give us that significant of an advantage. So they gave in the numbers, and the numbers look very good. And so with this, we wanted to try out how this does, and not just reproduce, but write an implementation in C++ and figure out how it evaluates compared to other encoding and decoding encoding schemes. So towards that, I think there was this doc that the community has accepted, and I think Julien, you just merged that commit. So some of the things that needed to be talked about, and the things where the new encodings need to be evaluated on. And also because it's a high bar that, it's a new code change, a lot of people use it, at least 20 to 30% improvement in one of these metrics is what we look for in the new encodings. So what we have done to evaluate is we picked around 2 data sets from the paper. The paper evaluated itself on 1024 values, but we wanted to do a slightly more set of rows. Around 15,000 is what we did, and we've clearly called out the lengths from which we got the data. And like 2 of these data sets which are present in that document, which I think was started off by Micah. So with that, I think a lot of you guys would have already gone through the paper and know the inner workings of it. I'm gonna straightly jump into what the performance numbers look like. So with that, okay, screen's still visible. So what we evaluated was these are the numbers from the Spotify data set, around 9 columns each in each of those, and there are 2 different columns available on the Kaggle website. And these are the 2 data sets that we have from the paper, 15,000 rows for each of them. So what that means is not just encoding at 1024 granularity, but we also have the metadata that's needed to stitch everything together. If anyone has any questions about ALP or wants me to go over it a little, let me know. I can just cover it in 2-3 minutes.
Micah, you raised your hand.
Yeah, I just had a quick question. Is byte stream split uncompressed here?
Yes. So we did not do anything on top of it. Based on some initial numbers that we got, if you do Snappy or LZ4 or Zstandard on top of it, the numbers look very identical to those, with very low overhead of stitching things together.
Right, yeah. But byte stream split by itself doesn't actually compress anything, so I'd expect it to be the same as plain, and then it should in theory compress better. But it's interesting that it didn't here.
So, Micah, I did not add compression on top of it. When I did do that, it was a little noisy. So I'm going to do that experiment again and publish the numbers again. So when we tried, it depends on the data set. At times it was, at times it wasn't. So it didn't look like the right candidate, but let me do that and share the numbers again for byte string split.
Yeah, thank you. I think it's just going to come up because I think byte stream split was something proposed for floating point specifically because we compress better, but I don't think that's a blocker. I think we should just kind of have it as a comparison point. I'm guessing
yes,
it probably will be, in the same ballpark, but
yeah, a valid point. I'll do that. So with ALP, what happens is, it's gonna sample the data. It's gonna look at your data. It's gonna sample equidistant values, figure out what's the right encoding scheme that it has to go forward with, and it picks two major streams. It figures out whether the numbers can be encoded as pseudodecimals, or the numbers need to be, there's no way of encoding them as pseudodecimals, but you have to, look at them as like real double values with high, precision points, and figure out if you can remove, the leading zeros or the trailing zeros. In the other scheme, it just looks at the leading zeros. Because of high precision, the trailing zeros are not that large a number. So with that, and the numbers in here are in bits per value. The number of bits that are needed to represent a value, so that's what the paper also does. So we wanted to make sure we do that and match the numbers with that. So with those 15,000 values and with everything, the metadata that's needed to stitch everything together, ALP tends to do very well compared to any other scheme, barring Zstandard. So comparing the compression ratio of ALP with Chimp, Gorilla, LZ4, like plain and byte stream split, doing the same thing right now, 64 bits being used to represent each value, Snappy, and Zstandard, it does very well. So the only contender in terms of compression ratio for all these data sets ends up being Zstandard. And when you compare it with Zstandard, ALP tends to do, sit within the 10-20% mark of it, which is quite good. And the reason it's quite good in the compression ratio is as we come to decompression speed, you can see that, everyone does well. LZ4 as expected can decode at a very high rate. Plain is just doing a mem copy over here. I'm not reading each and every value over there. Snappy, Gorilla, Chimp, Zstandard, comparing it with Zstandard. And one thing to call out over here is I've used Zstandard compression level 1, not anything else. And the reason I picked it is I looked at the Spark default settings, and over there, the default compression level is 1. And the same goes on with LZ4 also. So with higher levels of Zstandard, the compression ratio improves a little, but the decompression speed almost halves. So I don't see anyone using that a lot. With that said, when you look at the decompression speed of ALP compared to Zstandard, it is 11x better, which is a pretty significant difference. So with sitting it with it being close to Zstandard in terms of compression ratio in the 20% mark, giving around 11x speed in decompression makes it a very, very strong contender for floating and double point numbers. And again, because you've seen it 64, this is the numbers. I've done the calculation, encoding the data as double because that's what the paper also did. With that, I think we can look at compression speeds also. And compression, we haven't focused heavily. There are clear opportunities where we can improve on the compression speed, and we did not stress a lot on it. So this is, take it with the most basic implementation of compression that we wrote. ALP tends to do pretty good, but Chimp and Gorilla clearly went with their, XORing operations, which tend to be very fast. But it's on par with Zstandard in terms of compression ratio, but I clearly feel we can do a lot better over here. Andrew.
Could you just confirm that this is a custom implementation of ALP that you guys wrote that you're comparing, that you're reporting numbers for?
Yes. So we looked at the paper and that's and then based on that we started implementing it. There might be, because the paper is pretty clear in terms of how you do it, like how you sample the values and how you do the real double thing. So when looking at it, I think they looked like DuckDB is also probably doing something similar, but this is our own implementation. I think that Jonas built. Yeah. But again, I think they would be, it's like, how many ways can you write a bubble sort? It'll look very identical. It'll be very identical to other implementations that might sit out there. Yeah.
So that's the question, Silent. This is all comparing like C++ implementations of
Yeah, this is only C++. This is just C++ implementation.
And I think this was brought by, I think ALP uses kind of fast lanes underneath the hood. Is that?
Yeah. So we did not. Good that you brought it up. We use the naive bitpacking. Fast lanes representations of bit layout is something that we did not try. This is the bitpacking. I looked at the arrow code, and I don't think we have a fast lanes layout. We have bitpacking. So that's what we wanted to evaluate on. Fast lanes can give advantage, especially when using those SIMD instructions. I don't think you will have to write custom code in order to get values from different lanes.
So yeah, I guess there's like you're talking about the reordering of like the tuples in fast lanes.
Yes,
right?
Yes.
Okay.
Were you pointing out to something else from the fast lanes?
No. I thought I need to go back and review it. I thought like by its nature, one of the points of fast lanes is like most of the code would auto vectorize, so you wouldn't need to like write something super complicated to.
Oh yeah, I think the way they do it is just tight loops and hints to the compiler, not actually writing those SIMD instructions for Intel or ARM, but just indicating that.
Okay. Yeah.
Big pitch of the paper is they describe that they structured their code in such a way that compilers could auto vectorize it.
Yes.
And they compared it to like some handwritten version and showed it was basically the same. Yeah.
So like very likely what that means is, the code is just very tight loops, and you would see like in that showcases how you would calculate, how you would bitpack the data.
Yeah. Yeah. No, it's something that's interesting. I mean, I think one of the things to consider here's numbers look good. This might be like a place to like start thinking about doing the hierarchical encoding where we kind of separate ALP from the actual bitpacking method so that we could like add fast lanes at a later.
Yes. So we've written the implementation such that, we can plug in a library. But again, so one thing to call out is, in order to achieve the numbers earlier, what we did was we built on top of the helper libraries in the frameworks that we have access to. The numbers may differ, 5-10% here and there. But I looked at the code from Arrow, and I think the bitpacking code has all the performance things that it has. So the number should look very identical. But as we go ahead and implement it over there, expect slight variance. But we'll write the code such that you can write your own packer.
Yeah, it's just kind of like a metadata design. We might want to like revisit the like flat structure for encoding. So we like that's kind of the design decision, whether it's like ALP with existing bitpacking or whether we actually move to something which is like ALP with a pluggable, like if you model as like ALP on top of a pluggable bitpacking algorithm for like the actual implementation.
So the way I understand it is, you look at the values. You know, it's fast lanes and frame of reference. You look at the frame. You figure out the delta for everything. Once you've reduced the space of the data and subtracted it from the frame or the bias. At that point, you have those 1024 values, which you can pack the way you want to. And the unpacker is just going to give you back the values in the same order. That's what fast lanes also say. That once you give me those vector of data, I'm going to pack whatever way I want to. But when I unpack it, I'm going to give you it in the same order. Layout so the implementation should work with whatever layout one wants to.
Yeah, I 100% agree. I'm just saying the way encodings are currently modeled in Parquet is kind of like a flat enum. So like we don't have a way of saying like this is ALP on top of the current big packing. And like if we want to substitute ALP on top of fast lanes later, like we might want to consider that in like how we model it up front. Like it might be time to like add in a separate model that says here's the bit packing algorithm we want to use.
Valid point. It might cause. I think that's right. We can do it that way, or it can also be done. ALP comes with metadata as a versioning, some metadata that goes in the header itself.
Yeah, that's another option. That's a good point. Okay. Cool. Great progress.
So yeah, I think these numbers look quite promising, and we have evaluated across the data sets from the paper itself, and with this lot larger number of rows, so it's statistically meaningful, and from the data sets which on the doc that community proposed. Next step for us is going to be doing it in the Arrow code base, Arrow Parquet code base. Thank you. Yeah.
Thanks.
Sorry, can I ask what conclusion would you like to draw from this? Is this like your recommendation is we should proceed with ALP, like getting ALP ready for a formal edition?
As a next step, we just wanted to evaluate on a few more data sets. And with that, the numbers look very good. So if the numbers continue to hold for those of like a few more data sets, we should definitely go for a formal ALP adoption. It's compared to every other scheme that has come out, like I think Chimp Gorilla, I think the paper has compared it with ELF and PTAS and a bunch of other things. It stands out from them in the decompression speed by an order of magnitude. It's not like 20% faster, 30% faster, 2x faster. It's 10x faster. So there is very low probability of things going wrong. So yes, few more data sets, and then we should have a formal voting process, however it goes.
I think as is the document, you can share it, right? Like just to get some feedback, even like if we're not voting just yet. Okay. You could share what you've done so far and your finding and get feedback. I think I agree with Micah on like we need to figure out exactly if we just add an enum to the list, or if we can have a more like the better blocks style. Hey, how do you layer encodings, right? Like, oh, we have an encoding that turns floating points into integers, and then we have other encodings that take integers into a pack thing, right? So, and because that would be maybe a little more future-proof, right? Like, kind of, I think Vortex does that, right? Like they do do ALP on top of our Fastlane after ALP, and there's been a couple of papers, right, that talk about this.
Do we like? Are you suggesting that we should have a scheme where you can specify hierarchical encoding, or?
I'm suggesting we should have that conversation because I see others doing that, right? Like the Better Blocks paper is kind of talking a bit about that. I think it's a bit different. I think we need one thing we need to talk about a bit as well is the random access use case. Right? Like there's two main things on those new encodings, right? Like there's thinking in terms of better parallelism, right? So you can achieve higher throughput. And the other one is random access. I want to read the nth value. And how fast can I do that without necessarily reading all the values before it, right? So that if you do anything delta encoded, right, it's kind of, I cannot access the nth value without decoding everything before it.
Yeah.
In
this case, the paper clearly calls out, and this implementation clearly calls out that you can jump to values at that 1024 block boundaries as compared to those block compressions.
Yeah, I'm guessing we probably, I don't know if it needs an index or like it's more just like you can kind of scan quickly and skip over the 1024 bytes, but we can figure out those details.
Yes.
Yeah. So
that's a valid point, and I'll probably try to add that to the document. The metadata that will sit along with the encoding will have to make sure that one can do that.
Yeah, I think this is something to be discussed on the mailing list, right? So we should call those things out, and then there's a trade-off between simplicity and versus trying to be too future proof kind of adds complexity to the system, right? And then in the end, we need to be able to make some assumptions about what's coming in the format.
Yeah, makes sense. We just got the document ready late last night, so I'll share it with the team today itself. And just to add some credibility, I'll be sharing the sheet also, and I think Dhiren also laid out what the data distribution looks like for each of these data sets that we evaluated on, so that if people want to draw a correlation in terms of compression ratios, decompression speed, and the standard deviation of the data, and some graphs for you guys to visualize.
Is it fair to say that you're basically were able to reproduce the results reported in the paper? Is that basically good? Yeah. Okay. Cool.
Yes, on these data sets, yes, we were able to by I think almost within a 0.5 byte difference, I think. So almost exact. The metadata might be so. One thing to call out over here is if you look at the implementation that the paper shared, it's doing at exactly 1024 values. So 1024 values encode, decode, unless I miss something. So there's no metadata overhead. Metadata overhead is small, but still, that's going to make some difference.
That's cool.
Cool. Thank you.
Is there anyone else? So I think
I was going to say not. I'm going to butcher your name. I'm sorry. Not Narit.
Now, yeah, I was
Hero.
Now, Hero, I think you mentioned you were interested in that. Right?
Oh, I am interested, but I don't have any I can show right now. So yeah, I'm okay.
I think we can then when Prateek you're ready to share what you have found so far, right? Like this really will turn at some point. This will turn a very collaborative effort, right? Like working across systems and making sure those things work across things. So definitely, I think I would recommend we share this doc as soon as is humanly possible, right? Like I don't sleep at night, but and then we can collaborate on that on the mailing list, and then there's a fresh process to share progress on those proposals, so you can use it Prateek to get this going. And I think we can a similar collaboration that we did for Variant, right, on how we get this. We make sure we finalize a consensus, the details like Micah was talking about the stacking, like a few other things, and then think we'll be good to go. And then we can have a blog post also about this, and we can tell the world that Parquet is not ossified. Right? It can evolve.
Yeah, cool. I'll share that as soon as I go through some approvals. I'll share the document, the 3 documents, and then take it from there. Yeah.
Thank you very much.
Yeah. Thanks.
So next topic. So we have 2 topics. We have a logical type for scaled integers and suggestions for cookbook. So who wants to go first?
I can go first if nobody else.
Yeah, go ahead.
I'm Andrew Bell. I mostly work on very large point clouds. We are talking about kind of using Parquet to store point cloud data as opposed to the other formats that, or in addition to other formats that are out there. The main format the principal format for which there's like petabytes of tons and tons of data, stores most of our location data in terms of scaled integers. So there's, rather than storing floating point numbers, we store 32-bit integers, and then a scale and an offset are applied to that when the data is read, in order to get into the floating point world, which is what's useful for when you're processing the data. And this gives us 32 bits of precision, which is enough for almost which is enough for really every kind of way you'd want to sample data that represents the world. So I just didn't know what the process was for adding a logical type, or if this is something that would be entertained, or there's a better way to deal with it than ask this way. Do we just stick some metadata in somewhere, or?
Yeah, so I think there's a few different ways of doing it. Like there's a couple of documents linked in like how to go through like a process for approving this. This sounds a lot like the deck float type that was proposed a little while ago with lower precision. It sounds like you want to effectively store a 32-bit integer with like a separate scale number, which I think was effectively what deck float was. And the main, I think, objections there were like it didn't really exist in kind of like open source engines, but it might be worth revisiting that. The other thing that I think was being worked on and kind of it fell off. I think the person who's working on it, but we can pick it back up, is like custom logic, like essentially pluggable logical types, so that like if there's a use case that is a little bit more esoteric, we can have a logical type which can be standardized outside of Parquet and is maybe more lightweight. The like work there is to actually finish up the proposal for the custom logical types, and then that could also be a way of pursuing this. But yeah, typically like the process is like a discussion on the mailing list saying, here's what I want to do. And there's a link to the previous deck float thing, and then going through it, like, because this sounds like a different precision than the original deck float thing. We need to decide. And then like the other thing that needs to happen is like 2 reference implementations. And for this, I still feel for like deck float, like we should probably like figure out what engine is going to, like, is there some sort of like higher level project that will be using deck floats that we can actually like show that it's useful, right? Like I think Spark at some point will probably get deck float thing, but I don't know what the timeline is for that.
Okay, I guess Okay, well, I mean, I guess I'll just push this onto the mailing list, which is fine. I just didn't know what the process was, which is why I was asking.
Yeah, no. It's a great question, and like I don't know if all of what I said made sense, or there's any like follow up questions there.
No, I mean, it can be dealt with offline. So I'm not sure I got all the details, but that's okay. We can deal with that later.
Okay.
Thank you.
Yeah, and I think usually, a quick Google Doc that's easy to comment on for people, usually a good way to share the discussion on the list.
And I guess two other questions here, like if ALP is introduced, like would we still have the need for like this specific logical type, or would that handle kind of the compression and decompression on the fly? Like because I think what it is effectively doing is some sort of scaled integer stuff, but I'm hazy on the details. I need to reread the ALP thing.
Well, I mean, just in general, oftentimes when people are collecting data that represent, some area in the world, the range is really very, very small. Sometimes they need more precision than others, but typically the number of values that somebody, let's say, may need in order to represent their data isn't that large relative to the to floating point kind of representation. And so so you may have a very few numbers in an integer compression kind of a scheme is fine. And sometimes people don't even want the compression. But I don't know that, without doing comparisons and stuff, I don't know that ALP would or wouldn't be the way to go. But I mean, apparently you can encode this stuff, and you can compress it any which way you want, and that's fine. So some user could decide how to do it. But part of the thing for us, I think, we have so much data that is encoded this way. It would be really nice to just plop it in as it is, rather than have to like do something to it to change it to some other format. I mean, some other kind of bit representation.
So, Andrew, probably I missed. So one thing is ALP it's like this. Like I agree that most of the data doesn't look like actual floats or doubles. The data is very low precision, few decimal places, and that's what most of these values look like. But once in a while, you will see a value that might have a very large number of significant digits. So ALP can handle that in its algorithms. It handles that through exceptions and exception tables. Similarly,
I'm not saying that ALP isn't wonderful and won't work great for this, but it's just not the norm to store data in floating point representation for this stuff, generally speaking. And so, and that has been largely because of compression, and also just because we only need 32 bits, and 32 bits is a lovely number of bits to have. If you have single precision floats, you have 24 bits, which is not enough. And if you've got double precision floating point, you got 53 bits, which is too many. And so usually people are just storing this with that precision that's afforded by an integer. So,
but did I hear correctly that it gets materialized into a floating point number?
Usually it can be, it doesn't have to be.
Yes, I think the ingestion pipelines will probably, strip any extra digits that might come in. But I've seen a lot of customers having floats and doubles in their schema. Maybe they don't need it. Maybe they think they need it 1 year down the line. So from that perspective, I see pretty good number of schemas with floats and doubles in it. Even if and that's what ALP tries to reason at, that your data may not look like, but you're going to represent or model it as a float or a double, and we want to give you the flexibility of being able to handle your exceptions, being able to handle data changes, and hence we'll make sure that you have to model it as float, and we ensure that we'll encode it the best way, knowing that you will not need that many significant digits. So and the algorithm empirically proves itself to be pretty superior in terms of compression and decompression speeds with that assumption.
Yeah, I mean, I think what maybe Prateek is getting at, like, when we're making the proposal, it seems like maybe there's an argument to be made for like a custom logical type, because you get better compression as you already represent it as like the integer with the scale, like, but it's but we don't know that, right? So I think like there's a lot of questions here about understanding the use case and understanding alternatives that like might be more general than this this thing is. I think.
Yes, I think that's a question for how do you model the data best. It's like you model the data as variant or structure types. Many times you don't know upfront how the data will change. So.
Well, it sounds like in this case, it's a very specific use case where where I guess it's been proven that the data doesn't really change. So, yeah, I think the other thing is, as part of the doc, is probably a little bit of more education for people who are coming more of this from like a database systems
makes sense
process than a point cloud processing process. Which,
yeah, this. I understand that. I mean, it seems like a lot of the discussion, the Parquet discussion, is kind of database driven, if you will, and that's not where we are. And so we may organize the points that are in the data in a certain way, but certainly nobody's going to go and look for, like you're talking about, reading certain records, or if you will, nobody cares. Point cloud, nobody's going to read some random kind of data. And you have other requirements, and the question was, just might this work for point cloud stuff? And I'm just sitting with tons and tons and tons of data that's already written this way. And so I just was wondering, is there an easy way to kind of make a transition?
Yeah, it's like on the surface, like without having thought through, it sounds like this would be a really good use case for like pluggable logical type, saying like we have this scaled integer representation that's stored as a struct or something in Parquet, and then you can read it back or something else, rather than like this specific implementation. But I think probably needs some more thought and more understanding of the exact the exact use case, which is probably done better offline because it's hard to process in like a 15-minute.
And I want to save the last 5 minutes for the other topic that we said we save the 5 minutes at the end too. So let's say, Andrew, a good follow-up would be to follow up on the mailing list with a little, like you explain your use case, and I think we can have the discussion on the logical type versus pluggable type thing.
Thank you.
Thank you for bringing up your topic. Go ahead, Arnav.
Hey, Julien. Thanks for the time. So I was going through some issues recently on Parquet, and it looks like folks are raising issues that Parquet documentation is like 10 years old, and it's a bit hard to onboard to Parquet. So I was planning to start a cookbook and just wanted some thoughts from the community. First, would this be desirable or valuable for the community? And second, any suggestions that we'd like to get added to the cookbook. So I was planning to have something like the Arrow cookbook, which I think is really good. Maybe we could have some examples to get started and then dive deeper into specific components of Parquet, things like file format, like encodings or logical types or anything else. So I think this would in general make it easier for newer folks and the community to onboard to Parquet, but just wanted to know what you guys think.
That sounds like a good idea to me. Yeah, please do. I think, we want more people to contribute to documentation or things like that. You contribute to the Parquet website with a PR, I think. So yeah, I think, yes, please. We would be grateful. Thank you.
I'll share an initial documentation maybe on the mailing list. Once it's ready for folks to get reviewed, we'll add it then. Thank you.
Yeah, I think Google Docs is easy to comment on. I don't know, or whatever works best for you. If you want to do Markdown thing, that works. Cool.
Would love to. Yeah.
Thank you. Actually, I had a encoding related question still, if we have time. Is anybody interested in trying FSST in Parquet, right? Like have a similar bake-off to look at the benefits of it? Because this is the other encoding, right? Like, so we didn't have a good floating point encoding, and I think we don't really have a good string encoding either, if it's not a dictionary encoding, and the string delta encoding that we added a long time ago. Like, I talked to the person who implemented the decoding Parquet on GPUs, and he was like, why did you design it this way, right? Because it's assuming strings are sorted, and it's encoding by saying the command previous delta, right? With previous prefix with the previous string. So of course you have to decode everything in order for this to work. So it's really hard to parallelize. And in the same idea of, we talked about more parallelizable encodings, and better for the newer hardware and all that. And I think this is the other thing that Vortex is implementing that is standing out from recent research. So anyway, anybody looking at that wants to contribute, I think that's the other thing we probably would want in Parquet.
I would be happy to contribute. I don't have too much context, so I can maybe let me read more. Would love to contribute.
Yeah, well, their FSST paper, you find it. Yeah.
Julien, when you say more parallelizable, it's like not interdependent, like each and every value is.
Yes, so like FSST is kind of like a dictionary encoding, but you take subset of strings, right? And so you turn those strings into integers, basically, or like this. I forgot the details, but like what versus the delta encoding? We have a string delta encoding, which is every value depends on all the previous ones. Right?
Yeah. FSST also has the property similar to ALP that you can apply certain predicates to it in its encoded form, like equality predicates specifically, and so you can quickly not have to decode it in order to evaluate a bunch of the common predicates.
Yeah. Out of curiosity, has anyone in real world tried FSST and seen the advantage?
The Vortex guys, it's in the Vortex file format. They have done it, and they've basically reported similar results to what the initial paper reported.
Okay.
They have some other validation, right? Because it's in the context of a larger system.
Okay.
Yeah, and I think maybe it'd be great if people are interested. Like, I think it might be worth, like, if ALP is something we're pushing for, like, see the documentation and, like, because it looks pretty thorough, and I think that's probably going to be a good model for, like, how we do other things. But if people want to jump on FFST, great. And just going through the model once without, like, trying to do it in parallel might reduce churn in terms of, like, things we learned that we want to think about or review. Not to slow anybody down. I don't know that there's a risk of that. But,
yeah, I think those two, ALP and FSST should be high on the list of things we try. Like, so ALP is happening, right? So ALP fast links. And And so if we also try FSST, then we'll have reduced significantly the gap between Parquet and the newer formats.
Yeah, and I think fast links is the last one that's kind of lurking there.
There was whatever, like Facebook just released some new thing that's making the rounds. I can't remember the 3-letter acronym, but
OpenZL.
OpenZL. But the doc looks great, but I haven't got any independent verification yet.
So I looked at it, and I think one thing that disqualifies it as like they are not guaranteeing backwards compatibility in the short term, which they say sounds scarier than it is, but for a format like Parquet, I think it actually is as scary as they.
It's the same idea as Nimble, right? Like Nimble is not a format; it's an API, and they recommend not implementing it, right? Like we just use the API. I think, but so that doesn't prevent us from looking at the ideas, right? Like people will look at the ideas, and we can. If OpenZL by itself is not something that commits to being backwards compatible, the ideas behind it are still like valid. So it's not about the project. I think it's about, the underlying techniques.
So here, it only guarantees. Oh, sorry, wrong link. It only guarantees next several years of decoding, which.
That's funny. Well, yeah, but Parquet would not depend on an external library, blindly, right? Like that's not what the project is.
Right. No, exactly. So I think the ideas are good. I mean, well, we depend on like Zstandard and LZ4 blindly, right? Like, so there is a question of like when OpenZL matures, maybe we do just make that as a plugin. But I think that we can say like it will be backwards compatible forever.
Well, and with the new encodings, we don't need Zstandard and LZ4 anymore, right? That's your point, Prateek, right? You can just remove them. Like, because we talk about Parquet being slow because of the block compression, but they're 2 layers, right? We have the encoding and then the compression, and the compression is optional, right? So I think the whole point is once you have good encodings, you can just drop compression altogether.
Yes.
And it's just a fallback when people are just putting random stuff that you don't know what it is.
Yeah.
Okay. Well, thank you so much for the contribution. I'm looking forward to see your document on the list. I haven't followed up on the blog discussions, but I think we should talk more about what's happening in the Parquet community. Like we should showcase the adding variant to the format. Even, it's other people's things getting integrated. It's fine, right? Like it's showing how we build consensus and get things in there. And and Prateek, if you want to talk about your like reproducing the numbers of ALP for Parquet, I think that can be also a topic on the Parquet blog, right? If you want to get more content in there.
Yes, that'll be good. As let me add a few more data sets and then that'll be
good. No, there's no pressure. Your timeline, it's right now the blog only has releases automatically added to it. So I think the bar is low for adding content to it.
Cool.
Thank you, everyone, and see you all in 2 weeks. And I'll be at the Snowflake meetup, so maybe I'll bump into some of you. Bye-bye.